Hi everyone, today we'll look at two example Spark programs. The first program does log mining, meaning you want to analyze logs, as in computer logs, to identify patterns and discover issues. Let's look at the program in more detail, which is shown on the left. Our Spark program first loads some log files from disk, in this case from HDFS. Recall that Spark can load and save data to a variety of data storage systems, and here our text files are stored on HDFS. Next, in the second line of our program, we filter the lines in the files so that only the ones containing error messages, in this case those starting with the word error, will remain. After that, in line 3, we do some additional processing, splitting the line into two parts and using only the second part. Next, in line 4, we call an important function called cache, which explicitly loads all the filtered data lines into distributed memory. This function is important because Spark by default does not load data into memory, because memory is a scarce resource. And there can be a lot of data that your program may need to use, but not all data is worth keeping in memory. Spark needs your help to decide on what to load into memory. Like Hadoop, Spark also uses a driver worker model, meaning there is a driver program that coordinates how a user's program is divided into tasks and how to distribute them across worker nodes. The first 3 lines of code we have seen so far have been creating and manipulating RDDs on the way. For example, in line 1, when we first load the data from disk, we get the base RDD. The second line that does the filtering creates a transformed RDD, which is an intermediate result that we get after filtering. Similarly, this intermediate data is then further processed or transformed by the third line, which does the splitting. The fourth line pushes the data into distributed memory. Once in memory, you can query the data quickly. For example, we want to first count the lines that contain the word full. Next, we count the lines that contain the word bar. These two queries we complete very quickly because all the data that we want to search through is already in memory. So it's possible to finish similar queries in seconds, even for terabyte scale data. We mentioned that RDDs can be automatically rebuilt if a machine dies. This fault tolerance is enabled by Spark's ability to keep track of all the transformations that are performed on the base RDD. We call this series of transformation a lineage. This means if a computer dies, Spark will replay the lineage of transformations to reconstruct the necessary RDDs. Now let's look at another example Spark program that does machine learning. Logistic regression is a common machine learning algorithm that does prediction. It is also an iterative algorithm in that it uses gradient descent internally to find optimal algorithm parameters. It needs to iterate through the data many times to incrementally search for and hone in to the optimal parameter values. Recall that Spark can speed up such iterative computation by loading into memory the data that we need to iterate through. And that is exactly what our Spark program does here. In the program shown here, at the end of the very first line, we use the important cache method to load the data in memory, which only needs to be done once. Then a few lines down, we use a for loop that loops through the data many times to optimize the vector W, which is the algorithm's parameters. So in a nutshell, a key consideration when we write Spark program is to identify the data that we need to iterate through many times and try and load that into memory to speed things up. Not surprisingly, Spark can be quite a lot faster than Hadoop MapReduce, up to orders of magnitude faster. Note, however, if you want to only run one iteration of the algorithm, Spark can actually be slower, as seen on the far left on this chart. The reason is that loading data into distributed memory can take time. In this video, we look at 2 example Spark programs and discuss how by storing data in memory, Spark can significantly speed up computation.